All right, the next part, it says just for each of the following, just describe the transformation of f represented by g. And so for the number 3, it says log base 5 of x, and then the g of x function has a 1/2 multiplied on the outside. It still has a base of 5. And then instead of x, we've replaced x with x plus 7. So there's 2 changes that have happened. I've replaced x with x plus 7, and I've multiplied by 1/2. Jacob, what's one of the changes then that has happened here? Okay, so the inside with x, this has caused us to go left 7 units. And then what else, Jacob? Good. Vertical shrink by 1/2. So multiplying by something on the outside is a vertical stretch or shrink because the number on the outside is 1/2. Being less than 1 but bigger than 0, it's a shrink. What if this had been a 2 out front? Lane, what would I say about this? If this had been 2 times log base 5, what would I say? Yeah, vertical stretch by 2. All right, number 4. F of x equals log base 1/3 of x versus now we have g of x is still log base 1/3 of x, but we've minused 1/4 off of the end. Notice the minus 1, I said 1/4, minus 4/3 off the end. Notice the 4/3 is not in parentheses like the 7 was. So what do you think, Hank, is going to happen with this function if the 4/3 is subtracted on the outside? Yep, this will just shift, oops. Shift down 4/3. Take a look at the next 2. Ezrin, what do you notice? Let's start inside with x first and then move outward. So what has happened because of this x minus 2? Okay, good. Right 2. Then we've got a 3, and we have a negative out front. So let's go with Macy. What does the 3 do? Good. Vertical stretch by 3. And then Cole, what does the negative out front do? Okay, good. Thank you. Reflect over x-axis. Question, Dustin?
Reflecting over the x-axis, what's that again?
That's multiplying by that negative 1 out front. That's negative flips it like upside down, so over the x-axis. All right, Gary, what about this? Let's go working inside with x here first. What's happening because of all this stuff? We had an x as an exponent. Now we have negative 3x. Not shift, but because it's the x is being multiplied by 3, there's actually, because of the negative, there's something happening, and because of the 3. So let's start with this negative. Because of the negative, this is a reflection, but not over the x-axis, it's over the y-axis. And then because of the 3, Gary said something horizontal. It's a horizontal, normally a 3 would be horizontal stretch because it's bigger than 1. But when it's inside with the x, it's opposite of what you would think. So this is a horizontal shrink by 1/3. And then we can say the plus 4 on the outside goes up 4 units. Does that make sense, Gary? Any questions on those 4? Okay. On the next page now, we're going to do this basically everything backwards. If I tell you a transformation, we're going to rewrite the new function. Okay. So in this one, it says, let the graph of g, so we know our answer is going to be g of x equals something. be a translation 2 units up, followed by a vertical stretch by a factor of 3. So I like to do these in 2 steps. It's not always necessary, but I think then I'm less likely to make mistakes. Step 1, 2 units up. That means I'm going to take the function, which was log base 1/3 of x, and add 2 on the outside. Notice I didn't put parentheses and put the 2 in with the x. The 2 is on the outside of the function. And then a vertical stretch by a factor of 3 means I have to multiply by 3 on the outside of that whole function. And then normally we simplify. If 3 is being multiplied by log base 1/3 of x plus 2, the 3 multiplies by the log part and by the 2. So this is 3 log 1/3 of x, log base 1/3 of x plus 6. And there's my final answer. I'm going to write the g of x with it over here. Over here. And notice that order does matter in that one. If I had done the stretch first, the stretch, the 3 would only multiply by the log part of this function, and then I would add 2, and the add 2 would just be plus 2 on the end. So the order does matter. Because I added 2 first, and then stretched it all by 3, the 2 had to stretch by 3 as well. And so order is going to be important, and that's why I do number these. Okay, any questions on that one? Okay, number 8 says, let the graph of G be a reflection in the y-axis, followed by a translation 4 units, and this is spelled wrong here. You can cross out my extra T there. Unites, units to the left of the graph f of x equals log of x. Okay, so Brittany, what do I have to do if I want to reflect in the y-axis? Okay, on the outside or do I? On the inside. On the inside. So the x actually, make myself a note, the x actually gets replaced with negative x. And so if I started with f, we won't even write the f of x because we know that's going to change to g. Log of x, I'm now just going to replace this x with a negative x. And usually what I do then is put parentheses around it. I don't know why, but just so it doesn't look like log minus x, even though that'd be wrong. But okay, translating 4 units to the left. Audrey, what would I have to do to translate 4 to the left? Okay, yes, you take the x, though, and you replace it with x plus 4. Why is that important? Well, if you said just add 4 on the inside, it would just be negative x plus 4, right? But this is actually, I'm replacing the x with x plus 4, which looks like this. The negative is still there, but the x gets replaced with x plus 4, which means really I have a negative x and a minus 4 in my log. Oops, and I should put g of x equals. And so that is something I noticed every chapter people make mistakes with. It's not just, oh, I'll just throw a 4 added inside there. No, x is actually being replaced with x plus 4. And because x already had something in front of it, that number, in this case just a negative 1, has to distribute to everything. Okay, number 9, let the graph of G be a translation 3 units right, 1 unit up, followed by a horizontal stretch by a factor of 8. So Elliot, what does the first part do? Translating 3 to the right.
No. Subtract 3. Replace the
Close. Minus 3, yes. You take the x, you replace it with x minus 3. So in this function, natural log of x now becomes natural log of x minus 3. Lane, what does 1 unit up do? Or what do we have to do to make it go 1 unit up?
Put a plus 1 on the outside of the parentheses.
Okay, plus 1 on the outside. So natural log of x minus 3 and then plus 1. Okay. Rachel H., what about number 3? Stretching horizontally by a factor of 8. If it's horizontal, it's on the inside because it's affecting the x. You want some help on it? Yeah? Who knows what to do with horizontal, in this case, a horizontal stretch by a factor of 8? Brittany? 1/8 x, okay? X gets replaced with the reciprocal. So in horizontal stretches and shrinks, you use the reciprocal. If it says stretch by 8, you multiply by 1/8. If it said shrink by 1/8, you would multiply by 8. And so x gets replaced with 1/8 x. So now we have natural log of 1/8 x minus 3 plus 1. And that's g of x equals. Please remember to name it g of x. That's telling me that's your new function.